Welcome to Study Loop.
We have that we want to determine, so we have this vehicle and the maximum theoretical speed that can be achieved over 60 meters of a car starting from rest. And we have a coefficient of static friction between the tires and the road of the pavement of 0.80. And we also know, we're told that there's a weight distribution across here. So the weight distribution on the rear wheels is 40% of the total weight, so 0.4 W. And on the front wheels is 60%, so 0.6 W. Now, we're told that the vehicle is starting from rest, so we know that the velocity squared equals the acceleration times the delta x. And so, in general, we have friction force from the rear wheels and friction force from the front wheels equals the mass times the acceleration. That tells us that that V, solving this for V and plugging in the equation here for A, we get V is the square root of 2 times the quantity 0.4 mu s rear plus 0.4 mu s front, all times G times delta x. And what I did is I basically just used two different mu's here because they ask us if it was four-wheel drive, front-wheel drive, or rear-wheel drive. So what's going to happen is I'm going to basically say, well, one of these is 0, or neither of them are 0, depending on the situation we have, the kind of vehicle. So if it's four-wheel drive, we know basically both of them are going to be 0.8 because we have friction forces from both the front and the rear wheels, drive forces. And so again, because we're talking about the maximum velocity you could attain over this, the friction force is going to be, the static friction is going to be this maximum. So any greater acceleration, the tires would start to spin. So what we have here in this case, obviously this just becomes mu s. So we have V equals square root of 2 mu s G delta x. That winds up giving us 30.7 meters per second, or 110.5 kilometers per hour. So now in the second case, we have, there should be an S here. The second case, we have a front-wheel drive car. So there's no drive force from the rear wheel, so that's effectively setting US for the rear wheel equal to 0. And for the front wheel, basically we have a friction force from there. So that, is just this friction from this coefficient of friction. So this term is 0. So we get V is the square root of 0.6 times 2 mu s G delta x. That gives us 23.8 meters per second, or 85.6 kilometers per hour. So we see we wind up with this factor of square root of 0.6, dropping the maximum speed down. Because essentially what you're saying is there's less traction. And now if it's a rear-wheel drive car, we're going to say mu s front is 0, so that the friction force, there's no drive force from the front wheels, and the rear wheels have the maximum friction. And so now this term drops out. And so now we have this factor of square root of 0.4. And then, plugging all of this in, we get that is 19.4 meters per second, or 68.9 kilometers per hour. So we can see that if we have four-wheel drive, we, have the maximum possible speed. Rear-wheel drive, or front-wheel drive next, we don't get, we lose quite a bit. And then rear-wheel drive, we actually, lose quite a bit more. So again, that's because, it's when you have a rear-wheel drive car, it's much easier to spin the tires if most of the weight is in the front, because you can't, basically you're not going to get drive forces. You're going to easily overcome this if you're trying to accelerate too rapidly.